what we have done here, we have produced a data. It means we are extracting the energy of a number. And the number energy can be described by these numbers. When you sum up all this, you will find a certain value. The 36 values here represent the location of number 5. Because in our classic or conventional mathematics, we have only one way to use 5. 5 equals 5. But here, it means that 5 can take 36 different values to accomplish a certain task. Quantum physicists wonder about the particles that can be in many places at the same time, but numbers do it better. Hello everyone. Welcome to the continuation of our series of lectures on the great revolution of modern physics. Actually, we are talking about the new theory of relativity we call the singular numerical relativity. And here, last time when I gave the introduction, I explained that numbers are relative. What is relative about numbers? It's very difficult for you to guess, because numbers, they are abstract things. But I told you also that numbers are real. Numbers are part of the creation. They allow us to communicate with our environment. I mean, all things that we see out there. Numbers allow us to do so. So, today we are going to study about the relativity of a number. So, what is relative about number? We don't know. Of course, in classic mathematics, 5 is 5 and nothing else. It means cannot be equal to 8, cannot be equal to 3. So 5 is 5, absolutely 5. But in real life, the value of a number is relative. That's in real life. What I mean by in real life, the way we use numbers, we do it unconsciously, but it happens. So relativity happens in the way we use numbers. I will give you an example. Tomorrow is your birthday. Then here comes your friend. He says, "Oh, my friend, you are preparing for your birthday. You know, I just passed by because tomorrow I will not be able to attend. I was supposed to attend. You know, I love you so much, but I could not attend tomorrow because I will be busy with my boss somewhere. And I was supposed to buy you a gift, but I had no time because all the time, really, my boss disturbs me a lot. So I will give you only $5 for you to buy a gift of your choice." So please understand, the number is so small in reality. It's so small, $5, that's a small amount. but we need that small in order for us to understand easily. Because if we get big numbers, it will be a bit complicated. So you go to the store to buy the gift. Then you check around and you find a chocolate bar. Yes, it costs only $4. So you still have $1 with you. Then, since you have to honor the goodwill of your friend, then you have to obviously buy something else in order to complete the $5, because the gift is $5. Therefore, you check around again and you find a small candle, very beautiful candle, that costs only $1. You buy it. So it means when you have 5, you are not obliged to use the 5 as 5 for in a block, you know. You can break it down. The chocolate could be $3 only, and the candle could be $2 or so. But all 5, it's 5. So now, here you can go buying items worth of $5. It means you can break again here. Maybe you have here 111 plus 2, 1 1 plus 3. So you can have you can break down the 5 as you wish. But in the end, you will have only these values. The values you will have coming out of 5 are this 4, 1, 3, 2. In order, we say 1, 2, 3, 4. So it means 5 is like this. Inside 5, you have all these values, which are 1, 2, 3, and 4. Therefore, 5 is not just 5. 5 means 1, 2, 3, 4. 5. So if you want to know the value, the relative value of number 5, you have to sum up all these numbers, these values. If your number is 9, for example, so you have to sum up all the values below 9 plus 9 itself. You understand? So a number is like an antenna, like that. A number is like the antenna. This is an antenna. It has segments. And when you close like that, of course, it looks one piece. But inside, there are other segments. That's what we are trying to show here. So that's how number is structured. Therefore, to use a number, you have many options. You can break down the number as you wish. So 5 can be broken this way, broken down this way or that way, depends on you. You can do it 1, 1, 1, but all we need in the end, you have to buy goods work of $5 because your friend gave you $5. So you understand that in number inside number 5 there is 4, 3, 2, 1. That's what it means, relativity of number. So a number is relative that way. So you can compute, of course. You can calculate now the relative value of a number. But before we calculate the relative value of a number, I want to tell you how I came about this idea. How I came to understand that numbers are relative. I was just 5 years old. My mother got married again because my father died. As I was still a baby, my father died. Therefore, we had to move to another village, an African village, but where people build houses in bricks. So at least in that village when you go, it's not like the villages that they show you in the movies, but a village where you find beautiful houses like this. My stepfather, not to exaggerate, had the best house in the village. So he decided to build another house just beside that. Same size with the bigger house that he had already, but he wanted to build another house of the same size. Then he invited 2 of his friends to build the house. The friends are the masons, and himself was a carpenter. Then, as a child, I was there to watch what the masons were doing. Of course, I will help, bringing a brick or some water, whatever. So I was there. I was assisting. And I was attracted to something that caught my attention. Is the way they put the bricks on top of each other. So I found that after they build the foundation, so please consider this as a foundation, then they will start putting the bricks. They put brick number 1. But before they will put another brick here, because we build in order to cover up the space up, we have to cover the space. Therefore, we have to go up and put another brick here. But before they will put this brick number 2, they will go again, first 1, then 2. To put the brick number 3 here, it goes 1, 2, 3, 4. Sorry, 1, 2, 3. Okay, I went a bit ahead. So to go to number 4 here, we had to go 1, 2, 3, 4. Again, number 5, we go 1, 2, 3, 4, 5. So this, by the end of the day, if they didn't finish the wall, you see this beautiful thing that, anyway, even it is a graphic here, but the way they were building, really those guys were professionals. So I was attracted to that. And I became really obsessed with the beauty I saw in this kind of design. Then It followed me everywhere I went. Even when I went to school at the age of 7, in our school, we had to assist also to build the new classrooms because this is Catholic school, but that year we had many students, new students, so we had to build 2 new classrooms. And I went to secondary school. It's the same, high school, the same. I had the same situation. Everywhere I went, even in my missionary work, I had the same experience. Even there, I had to build by myself with my own hands classrooms for street children. Finally, one day I asked myself, I look at the brick. I see the brick number 5 here cannot be here without the support of all these bricks. Therefore, I think the value of a brick depends on all the bricks below it. The value of a brick depends on all the bricks below it. This is a very strange idea. But really, I was convinced. I saw that a brick, when it is here, it has a different value. Here, different value. Because that brick cannot be there without this structure. Therefore, the brick here depends on all these bricks. So these ones all are there just for the sake of this one, the number 5. Do you understand that? For decades, I believed that the value of the bricks on the wall are different from the end. That depends on the location of the brick. So if it is on level on this row, 2nd row or 3rd row, it will have a different value because the number of bricks below it is very different. So all the bricks do not have the same value. In terms of money, of course, it's similar. But what I was saying here, I didn't think about physics. I didn't think about anything, but just the value. Value, I don't know how I was seeing it, but that's what I realized at that time. That they had different value. Then, so the value of a number depends on all the numbers below it. I have already demonstrated this antenna. This one has, I think, 8 segments here. But here we have number 5. I said that inside 5, if you have 5, inside 5 there is 4, there is 3, 2, 1. So when you pull the number, the values, you can bring them all out one by one. And you can bring back like that. And now you can calculate the relative value of a number. To calculate the relative value of a number, you have to sum up all the numbers below that number. It means starting with 1 to that number is here from 1 to 5. And that's, you have 15. You will have 15. Then to calculate this, you see 15 equal 5 times 5 plus 1 divided by 2. So this is the formula for the calculation of the relative value of a number. So if you want to know how many bricks are below the brick that is on row number 14, for example, so you just get number 14 here, number 14, multiplied by 14 plus 1, that's 15, then divided by 2. That's the number of the bricks that you will find in the brick number 14, on the row number 14. That's exact. So you can write it again this way, in a simple way. If you want, you can write it this way. Okay, n multiplied by n plus 1 divided by 2 all. That's it. Now, as you see here, the number must have a structure. Numbers have a structure. The structure of the number consists of what we call the levels of variability. So if you have a number here, when you count it, like number 5, you have to count number 5. We'll say 1, 2, 3, 4, 5. How many times you go? So if you start here, you have to take only 5 steps you will go to count this number. So you will go 1, 2, 3, 4, 5. You can't exceed 5 because that comes from your mouth. So when you count 5, 5 only can stop here at 5. But now, these are called the levels of variability. So these are the levels of variability of number 5. Then if you want to know the number of levels of variability, you have to add 1, because here initially 5 has its own place. Then when you are counting it, you consider like 5 is moving. 1, 2, 3. How many times to move? It has to move 5 times. So every step it makes, that's a level of variability. Level of variability. Therefore, the structure of number is like this, that a number will have these levels, and each number has how many levels? The number itself plus 1. So this is what we counted, that initial level, this is the initial level or location of a number. That's a level 0. Then we go here, level 1, level 2, level 3, level 4, level 5. And why we need to know this? Because we are going to study what we call the vibration of numbers. Numbers vibrate. And they have, when they vibrate, they can go only to a certain, up to a certain level. So it means 5 can vibrate, can go pam, 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 pam. That's 5 times. I don't know if I completed the 5 times. So it counts 5 times. Just imagine like having fireworks, no? When you have fireworks, then you see boom, 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 going like that. That's the way numbers work. Then, so we have n plus 1 is the number of levels for each number. Simple as that, n plus 1. That's the number of levels. So if your number is 19, you will have 19 plus 1. That's the number of levels for number 19. So it will have 20 levels. So you have to go 20. When you are counting to 19, so you have to go 20 times. Oh my God, that's a lot already, 19. So next, we have said that numbers vibrate when you count them. So if you have a number, it is vibrating into this to the levels of variability. It will take a different value at every level it goes. So here we are talking about the prime values of a number. But at first, we have to determine these numbers because the numbers are limited and we will have minimum and maximum prime values. So when the number 5 will vibrate, it will go like that. So you see, the number has vibrated. It moves to this level 1. It takes 4. Here it means it is reducing, and here it is increasing. Minus 1 plus 1. Minus 2 plus 2. Minus 3 plus 3. Minus 4 plus 4. Minus 5 plus 5. So these are called the minimum prime values of number 5. The one on the left here, going down. Going up, these are the maximum prime values on each level. Now what happens? That when numbers vibrate, they don't just vibrate in doing this, as I have demonstrated here, taking these values only, but they vibrate also inside each level. Why? Because for these numbers to be stable, as they are here, for them to be stable, they need to communicate. They need to establish a relationship. So 4 will communicate with 6, 3 will communicate with 7, 2 will communicate with 8. Then here we have 1 will communicate with 9 and 0 with 10. Then to communicate here, 0 cannot go straight to unite with 10. He must pass through other values, meaning 0 must become first 1, 2, 3. So we will have this. You see here, 0 must pass through 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 10. You can't go from 0 to 10 immediately. No. Numbers obey a rule. The rules of number is that you have to pass through strictly. You can't go from 4 to 6 without passing through 5. So in order this number to increase its value, because what it is doing here is increasing the value or decreasing its value. I will show you what I mean. 6 wants to go to 4. So it will decrease its value passing through 5, then it meets 4. And in the opposite direction, for example, 3 wants to go to 7, communicate with 7, he must pass through 4, 5, 6, 7. Then that's why these are the middle values, and all together now they make what we call the prime values of number 5. So among the prime values, you have to know that they are maximum, and minimum. For every number, it has maximum and minimum. Please, this is a very important, because it will help us a lot to understand. And what we have done here, we have produced a data. It means we are extracting the energy of a number, and the number energy can be described by these numbers. When you sum up all this, you will find a certain value, and we are going to do it in a while, so we no need to anticipate. So here, what we are interested in is number 5. When it vibrates, can occupy all these locations. So how many locations we have for number 5? Here, 36. The 36 values here represent the location of number 5. Because in our classic or conventional mathematics, we have only one way to use 5. 5 equals 5. But here, it means that 5 can take 36 different values to accomplish a certain task. Quantum physicists wonder about the particles that can be in many places at the same time, but numbers do it better. Number does like this. Numbers do it better. You see, for number 5, it can occupy all of this, 36. That's a lot. But just hold. We will have, when we have the physical operations, then you will see that we can increase this number of locations for number 5. And what it means, follow the mathematics simply. If you don't understand yet what I'm saying here, in the long run you will understand when it will become more and more elaborated. So you will understand what I mean here. So you see, to calculate the 36, we have to get the number of levels, which are 1, 2, 3, 4, 5, 6 squared. So this is the number, to get the number of possibilities to use number 5, we have to just get 5 plus 1 squared. That gives you 36. So you get from any number, just get n plus 1 squared. So as I'm saying here, the number of values or locations is directly proportional to the square of the number of levels of variability. That's the law. Then here, as you see, we have a certain data. We have a data that has been given to us, and we can use this data here to develop a lot of equations that will appear here. Many. We can use this as the data for number 5 in order to gather all the information about number 5. But let's see, we have to progress. We analyze now the data. Here we see per level. At level 1, at level 0, of course we have only one value which is there is 5 if you compare to the one we have seen before. Then here we do we demonstrate how we can calculate all the values that number 5 proposes to us. These are the results that we get from the data that we have. So we are analyzing this data, and we found out that this is the level number, then number of values per level, you see it, and number of, no, here it is actually number of values up to the level. I go back here. I think I have to go back. Previous. We go back here. You see here we have levels. Each level has a certain number of values, and you can sum up all these values. They give you a certain result that you can calculate. There is a formula. So those formulas is the one I'm reproducing on that table that I will show you again now. And this is, so you have here for every value, every level, so you have the value on the level, and you can also calculate the whole, so including if you are on level, this is level 2, so you can compute all of this from level 0 to level 2, put it together. This is also one possibility you can do. So in your calculations, you can gather the data from here on the level and up to the level. That's what I call up to the level. Up to the level means, for example, up to level 3. So from level 0 to level 3. Up to level 5. From level 0 to level 5. So you can break down everything here as you see here. So you can calculate on the level and up to the level. So you can consider, and all appear with very beautiful formulas that we are going to see right now. So let's go back to what the analysis here. We are doing the analysis. So you have all this. This is the number of levels. So in overall, so you have 5 plus 1 levels. That's 6 levels. Then we have already calculated here. You have the sum of all the values. So the values here. How many values? This is from every level. So on level 5, for example, we have 11 values. Here you have 9 values. Here you have 7. Level 2 you have 5. And there is a formula in how to know how many levels, how much, for example, how many values you have on a certain level. So you have to get the level number times 2 plus 1. That's what you see here. Level number is the number 2 times 2 plus 1. Level number 3 times 3 plus 1. That's 7. So it's easy to calculate anyway. These are small things. They may look very maybe disturbing for some people, but it's very simple. Very simple. So here is the recapitulation of all we have done. Here is that you have the master number, which is represented by n. So every time you have the master number, so the number you are using, your base, is called base also. The base, for example, here we are basing everything on number 5. So 5, that's the master number. The level number is always expressed as a small n. So if you see small n like this, it means it represents a level number. That level number can be level 1, level 2, level 3, level 4, so those are what I'm talking about, level number. Level 0. Then the minimum and maximum prime values, to calculate the maximum and minimum prime values, I have already shown you how to calculate that. So you just add, you get the master number minus the level number for minimum, for every level. Here we go maximum, you have to get the level, the master number plus the minimum. These are things you have to really practice for you to really understand this. But you can do it alone, trying to, because it is used for analyzing the data. So if you are a data analyst, you have to learn exactly to do this, because this will be very important in the near future. You see them simple as this, but this is the way we are going to do data analysis. So we go here, number of levels. If you want to know the number of levels, of course, that's I said already, n plus 1 for any number. Then the number of values of a level, on a level, you have to get the level number times 2 plus 1. I also demonstrated already that one. Here, the total of prime values, all the prime values, that's what we say, that you have to get n plus 1 squared. So you have to get all the levels squared. Then you can also calculate the sum of values for every level. You can calculate also the sum of all the values on a level. That's it. So these are the things that we can do. But this is must be practical. Actually, you have to, in the classroom, really, you have to practice this. I can't give everything or do give exercise at this point. No, we cannot do that. So just keep this as your reference in the future. You have to do all these small calculations. Very simple. Now, let's talk about the physical properties of numbers. When we say physical properties of numbers, we have seen that you go to the store, you have 5 pesos with you, you can cut the 5 pesos in pieces, and that means a lot. It means what? A number can take different values. It means 5 will use 1, 2, 3, 4 to fulfill a task. $4 will go here, $1 will go there, $2 will go there, and another there, the other 3 there. So that distribution you are doing is what we call, and the number can take different values, and those taking different values, of course, to fulfill many tasks. So a number can appear in many locations at the same time. It means, we are going to give you an example of that. I don't need to explain. A number can fulfill many tasks at the same time. It means buy a chocolate, buy a candy, buy anything. The same $5, you can use them to buy 4 here, 3 there, 2 there, and another there. So this is but let me give you a very concrete example that we need to know. You know, we go for Olympic Games. Last year or this year? Yeah, last year we had Olympic Games in Japan. To go and perform or play the Olympic Games, we go as a nation. That's fundamentally the idea is like that. That each nation will go to play the games. But do we bring the whole population of the nation? No. We select only some teams. So we can select team of swimmers, boxers, football players, basketball players, gymnastics, acrobatics, whatever. So name them all. Martial arts. You can have different teams like that. So each team represents the nation, the 80 million people of the country. So if the team will win, the victory goes to who? To the country. That's the spirit of Olympic Games. You win not for yourself, but for the country. Even if you will be paid later, given some whatever, but the medal you are carrying there is for the nation. You understand what it means? And that's the power of numbers. It means the 80 million, instead of going 80 million people to go for swimming, competing with another maybe 30 million of people, so we make only a team of 16, for example, for swimming. They are the one who will perform. But victory or defeat of this team here of 16 belongs to who? to the nation, to the 80 million. So the pride of the nation is in the hands of this one. Even if only one person, a boxer, one boxer only. Defeated? Oh, the Philippines lost. The Philippines lost. He won? Oh yes, the Philippines won. So that's what it is. So what we are trying to show here is that a number can take different values, all the values below him. So this is all the small numbers here are below this. So 80 million can use 16, can use 1, use 11, use 5, 38, whatever. Any number you want below 80 million. You can use a whole army, for example, to go and fight a war. That army is the nation of 80 million. Victory or defeat belongs to the nation. So what transpires here that the number now, for example, in one day, you have a game. This swimming, they have a game. Boxing have a game. Football has a game. Basketball, and all these games are taking place in different colosseums or in different arenas. Then you will hear, they will say, oh, there, Philippines is winning. There, Philippines is losing. There, we got a bronze. We got a gold. We got a silver. So all of that playing at the same time. So number can be in many places at the same time this way. It means the 80 million Filipinos, or well, this is not the real number of the Filipinos. I'm just using the Philippines, but the Philippines has are around 100 million people. So understand that. Well, let's say that we have 80 million. The 80 million people are distributed in different places, and they are accomplishing the task of one. So the task of 1, 11, 5, 12, and 16 goes to the 80 million. So you understand now that that's the way numbers work. No, so numbers allow us to be in many places at the same time in this way. In this way, numbers allow you to be in many places and fulfill many tasks at the same time. So let's move on. Let's talk about this increase and decrease of value of a number, because that's where I think problem of understanding that a number can take a different value. When I say number can take a different value, so it means number can increase or decrease its value. So how it works? This is an example. You are looking for a recipe book like this. Then you roam around, you cannot find. Many places you go, you can't find the book. Then all of a sudden you arrive in some corner there, then you see someone selling the book. And you ask the price. The book costs only $8. Then, because you are very excited, you have found the book, you give so much value to that book. Then you tell the guy, oh, keep the change. You have $10, okay? Then you give to him Normally, he must return to you $2. But you say, keep the change. When you do so, you know what happens? You create inflation. Inflation. Inflation, it means what? Here, that you increase the price of the book and you reduce the value, you devalue the money. The money is devaluated. So it means the guy who was supposed to have only, because he put here $8, but you gave him $10 by letting him keep the change. So you are the loser. You are going back home with this book that costs only $8. So your $10 become $8. In reality, you are going home with $8. And him, with his book, which was supposed to be only $8, is going home with $10. So he's increased and decreased. So here we see what we call inflation and deflation of a number. So we will be talking, these are terms that are going to be used in our calculations. The inflation of a number. So number can increase its value or decrease its value. Decrease is deflation or devaluation, what you call devaluation or inflation. And inflation, that's you understand, it's very easy. That's an increase, inflation. So it's a very simple thing that I want you to understand. Then the last point here is we are going to talk about the simplicity of the mathematics that we are going to study here. You know, you have been studying mathematics, and as you see here, the mathematics are only n plus 1 multiplied by something like, very simple mathematics. Why? The mathematics you have been learning, they are mathematics that explain the details of the universe. And those details, the universe is like a tree. So you see leaves, flowers, the crops themselves, and many things, the roots. If you are studying this, of course, you need many complicated formulas. You need to write many books for you to study all of this. But I told you that the mathematics we are going to study is only mathematics of the singularity, leading to the singularity. And you know that the singularity in physics is the seed of the universe. The universe began with the singularity. Therefore, the seed is very simple. You see the seed, the peanut. How many parts you see here? You open the seed, it's almost nothing. You see only the two cotyledons. And then you have this embryo. Just that. Two parts you can read here, you can see. So it's a very simple. That's why the mathematics that will explain the singularity are very simple. Please do not underestimate what I'm showing here, because this is the solution. This is tomorrow. You may be great today, but tomorrow you will need this. And if you don't do it, even if you are a graduate of any university in the world, you need this mathematics, the relativity of numbers, because you did not study them in school. And that's why many things you don't understand. And these mathematics are going to take us to a new level, a new way of seeing the universe. You will see things differently. So it is coming to open your mind to a new dimension, because numbers are invisible. We are solving the problem that exists in physics. And this is the way, very simple things we explain. So the mathematics we study here are very simple, because it's the mathematics of the seed. The seed doesn't have many parts. There is not so much stuff to study here. But when you have the tree here, the mathematics you have been using so far explain the universe and many, many kind of things. So it's like the mathematics used to study a whole tree. So I would like to invite you again to continue with us. The next time, what we are going now to start is the physics of numbers. It means we are going to apply the physical operations to numbers in order to get the data from numbers, how to get data from numbers, because this is all about information technologies. Do you understand that? This is what is going to bring us higher, to a higher degree. Understanding that number can be used in many ways, this is very, very important. So please follow me again in the next chapter, when we will be discussing about the physical operations of numbers, because you know only the operations of addition, subtraction, multiplication, and division. That's all you know. But there are physical operations, which are five physical operations we will start seeing next time in the next chapter. So please stay with me and let's continue. I told you it will take more than maybe 20 videos for me to explain everything. So thank you very much. See you.